we're going to build an Express.js web server inside of these cloud functions. Express is a web framework, so just like .NET Web API or Ruby on Rails or any other web framework, instead of using the built-in way of handling HTTP requests and responding to these inside cloud functions, I think Express.js has a much superior syntax. And I think if you have more than just a couple endpoints, it is going to help you a lot. So in order to get started, we need to make an npm install first. So just go into your functions directory. So the same place as you have your package.json here, and then write npm I express. And we're also going to install a library for managing cross-origin resource sharing. So just like many other REST APIs also will need to handle CORS, we also need to do that this time around. So I'm just going to write npm I CORS like this. So just like with the above imports, we can use the require keyword and then just point to the library that we want to use. So I'm going to make a constant here and just call it app. And the way that we can start Express.js is by just making an opening and closing bracket here. You'll sometimes see people do the import like this and then write something like const server equals app and then do the opening and closing brackets here. But I'm just going to do them right here to save a line. And now I'm also going to import CORS. So when you start sending HTTP requests from a browser, if you don't have CORS enabled, you will get rejected. So we'll just start off by enabling this. So const CORS equals require CORS. The way that we can make sure that we're always using CORS is by just accessing our app constant here and write use and then write CORS here with an opening and closing bracket. So you can always put options inside of this. So there are options like allowed headers or origins or whatever, but we're just going to go with the default setup here. So every time we want to make an endpoint, the only thing we have to write is app and then the name of the request type. So for HTTP, we have get, post, put, delete, and so on. So let's make a GET request here. We're just going to write GET, and then the first parameter that we're going to pass in here is just the name of the path. So if you have some path, let's say you open up a browser and you write whatever here, you're going to get to this GET method, because when you paste a URL inside of your browser, that is automatically a GET request. And then we're going to make a function here. So the simplest way to make a function is just to write a lambda expression. And we're going to write two inputs into this function. The first here is the request, and the second here is the response. So we can get some data from the request, like the body or whatever, and then we can send a response back to the client. And let's just test this out by just responding right away. So we can write res, and then we can just write JSON. And then in here, we can just put some kind of object. So let's say my key equals hello world. And you can also make a return statement here if you want to. For this one, it wouldn't really matter. So right now we have defined the application, but we have not exported this as a cloud function. But we can do that using the exact same syntax as we've always been using, exports. I'm just going to call this API because this is just like a REST API, equals functions HTTPS, and then I'm going to write app here. So the Express.js application is the input to an HTTP callable cloud function. Remember, you could have multiple endpoints here and still just export this one cloud function. So let's say that you write app.get some other route and make a function here, res send. You can also use send. I rarely use send. I always use JSON. And some other key, some other value. And I just forgot to add this one on request and then put the Express.js application into this one. And if we open up the emulator by just writing the normal Firebase emulators :start command, we can see that we now have this cloud function running here. So right now, if you open one up, it's gonna say cannot get, and that's because we have a relative URL. So remember, we called the cloud function API that hosts the Express.js application, but the routes are relative to this route. So if I'm gonna say whatever here, because that's what we called it, we get this one back. And if we write some other route, we get this one back. So my idea for what we're going to build with the cloud functions today is a toxicity filter. You might have heard about Tensorflow, which is a framework used in machine learning, and they have a bunch of pre-trained models. And one of these models is the toxicity classifier, which can be used from a JavaScript application, which fits our tech stack because we're using Node.js, which is a runtime for JavaScript. And we can get started with the toxicity filter by just writing this npm install. So let's open up our terminal here. And inside of our functions directory, just put in the npm install here. And from the top here, let's just delete what we already have here. We don't really need all of this bloat here. And also, for now, I'm just going to delete these here. These were just for demonstration. So now the library is installed, and we are done indexing here with WebStorm. So the way we're going to do this is we're going to write const. I'm just going to call this one toxicity. You can call it whatever. And then we can require. And here we are going to use the TensorFlow models to add toxicity. So the way we're going to use the filter in practice is that some client wants to write a new message inside of the chat. Instead of letting the chat persist the data by directly accessing Firestore, what we're going to do is we're going to send an HTTP request to the cloud function. And then the cloud function is going to figure out whether or not it contains toxic speech. And if it doesn't, it persists to the database and returns back to the user. And we're going to follow convention by making a post request. So creating new resources would typically always be a post request. I'm just going to call it message request response. We can always refer to the body of the HTTP request by just writing request body like this. So if we make a constant for this one, we can just call it body like this. So let's say that the body contains a JSON, and the JSON may have a bunch of stuff. So let's say let object equals, then there could be like a user something here, and then there could be a message, and that's some string here, and then there could be like a timestamp or whatever. So if we just want to refer to the message of the body, we can just write body.message. So let's just assume that the message is what we're looking for here. We're going to use the TensorFlow model now, and I'm going to make it in a separate function so that when we call update or whatever, we can also use the same model so we don't need to duplicate code. So I'm going to write const is this message all right equals, and now we're going to make a lambda expression. So we're going to make an input for the lambda expression, which is the message. So this is just some string. And we're going to make this an asynchronous function. So the way we're going to use the TensorFlow, model here is we're going to initialize this. So we're going to make a local variable here called model equals toxicity. So we're going to use the variable we created here. And now we're going to write load. And since they haven't made a whole lot of effort into explaining what threshold and toxicity labels are, I'm just going to go into the docs here. So they're going to write here, load the model. Users optionally pass in a threshold and an array of labels to include. So we're just going to include all labels by default. And then the threshold is the prediction confidence. which means how sure are we going to be that something is toxic? So in this instance, they have the sentence, you suck, and maybe that is toxic. If you put the threshold at some given value, we're going to use 0.9 like they do in the results here as well, which means we are 90% sure that something is toxic. And since this is a promise, we're also going to await this one. We made this an asynchronous function, so we can do that. So once we have the model here, we can write model.classify. Right here, we only have one message, so this is just a string. And we are going to await this one as well. Const result equals await model classify message. So the result from the classify function here is an array of objects. So they have an example here. So they have a prediction that is coming from a classification, and these predictions, they could be identity attack or insult or whatever, and each of these different categories, they have results that are probabilities. So let's say that something is an identity attack, it isn't necessarily also an insult, and an insult isn't necessarily also an identity attack or any of the other categories here. I think the easiest way to handle the response here is just to make an array, and then if there is something wrong with the message, we're going to input that into the array, what is wrong, and then we can send that back to the client. So let's say let's what's wrong with message equals, and then an empty array, and then we're going to iterate over the results here. Result for each, and I'm just gonna write like this. So this is just a loop here. Let's just call this one prediction. Prediction. For each prediction, there is the result of the prediction. And if we take a look at the prediction here, we can see the prediction also contains the label and the results. I'm just going to rename this one just to alleviate some confusion here. I'm going to list this as predictions. So for each prediction in predictions, there are results. And for each of these, they have been nice enough to just put a Boolean that is called match. So we don't have to look at the numbers and look at these as numeric values and figure out, is this enough? We just look at the match here. So we just adjust the threshold here. And I know it says 7 right here, but I was just off camera for a while. So I'm going to write if result match. So if that is true, that we have a match, I'm going to just push the name of the label into the what's wrong with message here. So the result does not have the label, but the prediction has the label here. So the label of the prediction goes into there. So I know this is a nested loop, and typically we say, watch out with nested loops, but there is not a whole lot of data here, so it's not going to add a ton of latency. There is going to be a bunch of latency just because it's going to call the API to figure out whether or not it's toxic speech. And there are things we can do to speed that up later on if we want to. I'm going to return the list of what is possibly wrong with the message. And now we're going to use this one. So we have this post request here. Let's just move it down here and reformat here. Now, let's call the method we just created. So const results equals await. Is this message all right? And put in the body.message here. And the only other change I made while you were away or while I was away was adding the async keyword here. So now we know whether or not the message someone is trying to send is all right or not, which means we can persist this if it is all right. So I'm going to write if results, length 0, and I'm going to use 3 equals here. And that means there is nothing wrong with the message if there is nothing inside of the result. And then we can say admin.firestore collection, just put the name of the collection in here, and then just write add. And you can just put the entire body in here. So the body could contain all kinds of other data. And if you want to put any other data here, we can just write something like body, let's say you have timestamp. Body.timestamp equals new date. So we're adding a timestamp to when the message is being persisted. And I'm going to write const write results equals await. So this is a promise. And now we're ready to return this to the client. So you don't have to write return. You can just write res for response straight away. But I'm going to write return here so that I know the function will also terminate return res. And I'm going to put a specific status code here. So 201 indicates a write. And now I'm going to put the JSON here. And I'm going to write, just put the write result into the JSON so the client can get this one. And because we return here, we don't have to write an else statement. We can just write return res status, and I'm going to write 400. That means bad request. So if we get to this point, it means that there was something wrong with the message. And I'm going to send a JSON back, and I'm just going to write here message. You are being toxic. Let's write that. And let's also write results back to the client. Results, result, like this. So they get an array here of all of the things that's wrong with their message. We're ready to test this endpoint now. I have Postman here, and here we have the endpoint. So let's just create a JSON object here that has message on it. And now I'm going to write something that is maybe a little toxic. You are totally stupid. This is probably not the worst thing someone has written on the internet, but let's just write it. You are being toxic. We get that as a response. So we can see that this is insult and it is also toxic. So let's write something that says super nice. You are totally cool. And now we can see that we have a 201 response. So we can see that we are actually writing things. So this is the right result that we are sending back to the client here, which means if we go into Firestore now, we can see that we have written this message in the document that is inside of the collection called chat. So now the only thing we need to do is to make sure that the client is actually using this. So we're going to go into our Angular application and start using the Cloud Functions instead of just calling Firestore directly. So let's just go into the Fire service inside of our Angular application, Fireservice.ts here. So in order to get started with sending HTTP requests, we need a framework to send HTTP requests with. And the easiest way to do this is just to install Axios, which you might be familiar with. So let's go into our Angular application. We just call it frontend. While you're in the directory with the package, the JSON file, npm I Axios. And we know that we're going to have to import it. So let's just write that right away. Import Axios from Axios like this. And we're going to put the base URL of where the Cloud Function is. So in Postman, I posted the URL here. We can just copy this one and just write base URL. It's string and put. I just add API here. So I will have to concatenate message onto this one to reach that exact same endpoint. But then again, I could also use it for other endpoints. So the base URL here is just what we're going to inject into Axios every single time. So we have already a send message function here that goes into Firestore, and we'll just comment this one out. And now we're going to write Axios, and it's a post request. And we're going to put this base URL in here and concatenate that with message. And the second argument is the data. And we already have the data. It's right here. It's called message.dco. So we actually have a property called message content and not message. So I'm just going to change that in here. Body.message content. Yeah, that was close, right? We don't need to add the timestamp anymore because now the server does it. And let's just refactor this model here. And instead of putting some user in, like we've been doing so far, let's just write the name of the ID of the currently signed in user. So this auth current user UID concatenate with empty string. And this is a promise, so we can write then and catch. Let's just do that instead of making this an asynchronous function. So we only get into the then scope if we get a successful response. So we can just write success and console.log the success response here. And let's just only take the response body and log that. And then we can also make a catch statement here, and that is only in unsuccessful responses. So let's say that there's an error, we're getting it here. So right now we are not attaching any JSON web token or anything. We're going to look at that in the next video. So we don't have any security emphasis right now. This is just exploring some feature with Cloud Functions. So next up, we're actually going to integrate the authentication system we already have with our Cloud Functions, but I'm just going to let this stay as it is for now. I do think, however, that the name of the chat that we have here is my chat and not just chat. So I'm just going to minimize these and find the method for getting messages. It's this one, and it says my chat here. So chats, and let's not filter by user here, so we can actually get the data. And by the way, if you're using an emulator of Firestore, I also recommend using an emulator for the other services. So right now, when we're persisting data, we're persisting it into the emulator and not the Cloud Firestore. So if you're running your application and you also expect to read from Firestore, just make sure to read from the same place as you are pasting the data. And here we have the application, and we are signed in, and we're going to test the toxicity filter now. We know the result of this one. You're totally stupid. Let's try and write this message here. So it is going to take a little while to get a response. We can always look at how we can optimize things later on. So as we expect, we're getting a 400 error here. And let's just take a look at the data. And it says, just like we expect, you're being toxic. And it has the result of insult and toxicity. So we confirm that we cannot persist data if it's toxic. Let's try with our nice message. You're totally cool. Send message. So now it's in the emulator, and it is trying to figure out whether or not it's an okay message or not. And we get the response here. So this is the response from the promise rise. But remember, the way that we are receiving data from Firebase is by listening to changes. So the function that writes the data doesn't really have to return it to us. I just made it return the Firestore write results, but it doesn't matter if you put anything inside of the body here. This is from the Firestore reading connection here. So this demonstration is really just trying to give some inspiration on what you can do with something like functions.